Hello, this is Mrs. Boyd, and today this video is going to cover how to find proton, electron, and neutron number. So let's jump in. First, let's start with the easiest one, that is protons, and these tell you the identity of the atom. Great news about that, identity is always connected to proton number, and that means you can just look up the element and automatically tell how many protons it has. So, for example, let's take the first one, which is Pb. So we go to our periodic table and we look up Pb. We find out that is lead and it is number 82. And that means that lead has 82 protons. Now let's take a look at carbon. Carbon is element number 6 right up here. And that means it has 6 protons. So I love doing proton number because it's very easy. The element is always tied to the proton number. And by the way, that's also called its atomic number. And then, of course, if I tell you it is element number 12, that means likewise that it has an atomic number of 12 and it has 12 protons. Okay, now the second thing you might be asked to look for or identify is the number of electrons. And when you vary the electron number in an atom, then you are making it into an ion. So let's just take a normal standard atom like magnesium, for example. No clues anywhere on this about how many electrons it has gained or lost, which tells me that it hasn't gained or lost any. So all we have to do there is look on the periodic table, because magnesium, which has 12 protons, also has 12 electrons. So that's to tell you that a standard atom on the periodic table that has not lost or gained electrons has an electron number that is the same as its atomic number. So that's easy to remember. Now let's take a look at some of these examples. So here we have an oxygen, and the big clue is the -2 in the upper right-hand corner. What that's telling us is that atom gained 2 electrons. Now you probably think, why gained? It says -2, but electrons are negative. So this is oxygen, which has an atomic number of 8. And so we know that it would start off with 8 normally, but we know that it gained 2, so that means it's going to have 10 electrons. All right, what about this sodium +1 right here? Again, let's find out how many electrons it should normally have. Take a look at this periodic table. 11, it should normally have. But do you notice that it says +1, which means it actually lost 1 because it lost one of its negative charges. So 11 minus 1 equals 10. So sodium +1 has 10 electrons. All right, now before we get to the third thing you could be asked, and that is how many neutrons it has, we need to take a second and understand what the heck mass number means, because this is going to be a really important concept to understand. So if you take a look at a box off the periodic table, you will notice that, of course, as we've already talked about, there's the atomic number, there's the element name, there's the element symbol, and then below that is this thing called the atomic mass. It's always a decimal number, a number that has decimal points in it, and this is basically telling you, if you were to take all of the isotopes of carbon, that means all the different carbons out there, like the ones that have 6 neutrons, the ones that have 7, the ones that only have 5, and you took an average of like normal old carbon, like a sample of it, what would be the average? And that is what that 12.011 is. It's the average of all the different isotopes of carbon that are available. And the cool thing about that number is if you round that number, so if we take 12.011, we can round it to the whole number 12. Well, that now tells us how many neutrons plus protons, because those are the only things that have mass anyways. So that means that this carbon has a mass number of 12, which means it has, if you add together neutrons and protons, a total of 12 of them. Well, lucky for us, we know how many of those are protons, because we already learned that atomic number tells you the number of protons. So if we were asked, well, how many neutrons does it have then? Well, we would take 12, because we know that's the total, minus 6 protons equals 6 neutrons. That's how many we'd have left. So let's apply this to some problems up above. So when we start varying the neutron number, we are creating isotopes, as I mentioned before, of that element. So, for example, we have helium-5 pictured here, nitrogen-15, and fluorine, and I'm not going to tell you what the number is because that would ruin the surprise, but I'm going to show you how to find that in a minute from the periodic table. So let's take our first example, helium-5. Here's the great news for you. This 5 is the mass number. Isn't that so cool? So all you have to do is you have to take the number 5 minus, just like we did below a minute ago, the number of protons in helium. Helium is over here on the right, and we see that it has 2 protons. So we're going to take 5 minus 2 equals 3 neutrons. Pretty easy, right? Now, there's another way you can write it, and that could be where you have the mass number in the upper left-hand corner instead of after a dash. Sorry, apologizing for all those scientists who like to create a whole bunch of different symbols to represent the same thing. So we could have also written this nitrogen-15, right? So you just kind of have to get familiar with both models. All right, so let's take the one we give you, upper left-hand corner, but it is just exactly as above. 15 minus, let's take a look at the periodic table. We know that nitrogen has 7 protons, so minus 7 equals 8 neutrons. All right, let's take our last one, which is fluorine. No clues here. No upper left-hand corner, no something following a dash, and so we're like, how do we tell how many neutrons? Here's where the periodic table comes in handy yet again. So fluorine is over here, it's 18.99 something something something. Okay, right? Do you see that little number right there? Remember I just explained to you a minute ago that was called the mass, well, the atomic mass. You can round that to mass number. So we're going to go ahead and round that to 19. Remember, you might have to review your rounding rules. Remember, if it's above 0.5 or 0.5 and above, you round up. If it's below 0.5, you round down. So fluorine has a mass number of 19 minus, let's see how many protons, and we can tell that it has 9 because that's its atomic number. So 19 minus 9 equals 10 neutrons, and lo and behold, fluorine, the isotope of fluorine called fluorine-19, has 10 neutrons. All right, I hope this is helpful.